Hello, space explorers. Ever looked up at the night sky and wondered what's happening out there, beyond our protective atmosphere? We're not just talking about distant galaxies and twinkling stars. We're talking about space weather, a dynamic and often unpredictable phenomenon that can significantly impact life here on Earth. But what exactly is space weather? It's essentially the sun's influence on our planet, a cosmic ballet of charged particles, magnetic fields, and solar radiation. Think of it as the sun's ever-changing mood, and we, here on Earth, are right in the middle of its emotional roller coaster. We often associate weather with rain, snow, and wind, but space weather is a much grander, more powerful version. It's driven by the sun, our closest star, a colossal ball of fiery plasma constantly churning and releasing energy in various forms. This energy isn't just light and heat. It's a torrent of charged particles, called the solar wind, a constant stream flowing outward from the sun, impacting everything in its path. Can you imagine a river of charged particles constantly bombarding our planet? That, my friends, is the reality of space weather. The sun isn't just a steady emitter of energy, though. It's incredibly active, with its surface bubbling and erupting with solar flares and coronal mass ejections, CMEs for short. Imagine a gigantic explosion on the sun, releasing billions of tons of plasma into space at incredibly high speeds. These CMEs are like massive, energetic bullets fired towards Earth, carrying a potent dose of charged particles and magnetic fields. And these aren't just minor disturbances. They can have significant consequences for our technological infrastructure and even human health. But how exactly does this solar activity affect us here on Earth? Well, our planet has its own protective shield, the magnetosphere, a magnetic bubble surrounding Earth that deflects most of the solar wind. It's like an invisible force field, protecting us from the constant barrage of charged particles. However, during periods of intense solar activity, like powerful CMEs, this shield can be overwhelmed. Think of it as a dam holding back a powerful flood. Eventually, even the strongest dam can succumb to immense pressure. When the solar wind and CMEs interact with our magnetosphere, they can trigger geomagnetic storms. These storms are not just pretty auroras, though the northern and southern lights are spectacular consequences. They can also disrupt our technological systems. Imagine a world where GPS navigation fails, power grids collapse, and satellite communications are disrupted. This isn't science fiction. These are very real potential consequences of intense space weather events. Let's delve deeper into the specific effects. One major concern is the impact on power grids. Geomagnetic storms can induce powerful currents in long conductors, such as power lines, leading to transformer failures and widespread blackouts. Remember the 1989 Quebec blackout? That was a direct result of a geomagnetic storm, leaving millions without power for hours. Imagine a similar event today in our increasingly interconnected world. The impact would be devastating. Another critical area of concern is satellite operations. Satellites are essential for various aspects of modern life, from communication and navigation to weather forecasting and scientific research. Intense space weather can damage satellite electronics, disrupt their orbits, and even cause complete failure. This can have cascading effects on various systems, impacting everything from banking transactions to air travel. The cost of replacing or repairing damaged satellites is astronomically high, and the disruption to services can be equally significant. Radio communication is also vulnerable to space weather. High-frequency radio waves, used for long-distance communication, can be disrupted or even completely blocked by geomagnetic storms. This can impact aviation, shipping, and even emergency services. Imagine a scenario where air traffic control loses contact with planes due to a sudden radio blackout. The consequences are chilling. But it's not all doom and gloom. Scientists are constantly monitoring space weather and developing advanced forecasting techniques to predict solar storms and mitigate their potential impacts. We're learning more about the sun's behavior and how it interacts with Earth's magnetic field, allowing us to improve our preparedness. Think of it as a cosmic weather forecast, but instead of umbrellas, we need robust infrastructure and resilient systems. The study of space weather is a multifaceted field, combining physics, astrophysics, and engineering. It involves observing the sun, analyzing its activity, and developing models to predict its behavior. Space agencies around the world have dedicated missions to monitor solar activity, providing crucial data for forecasting and risk assessment. This data is then used by various industries and governments to develop mitigation strategies and protect critical infrastructure. Furthermore, understanding space weather is crucial for protecting astronauts in space. Intense radiation from solar flares and CMEs can pose significant health risks to astronauts during spacewalks or long-duration missions. Protecting them requires advanced shielding and careful planning of space missions, taking into account the current space weather conditions. We are only beginning to fully grasp the complexities of space weather. It's a dynamic and evolving field, and new discoveries are constantly being made. The more we learn, the better equipped we will be to protect ourselves from its potential impacts. But it's not just about protection. Understanding space weather allows us to harness its power for beneficial purposes. For example, we can use space weather forecasts to optimize satellite operations, minimize disruptions to communication systems, and even improve our understanding of the sun's evolution. So, next time you look up at the night sky, remember that it's not just a beautiful backdrop. It's a dynamic and powerful environment constantly interacting with our planet. Space weather is a reminder of our connection to the sun and the cosmos, a force that shapes our lives in ways we are only beginning to understand fully. It's a challenge, yes, but also an opportunity to learn, adapt, and innovate, ensuring that we can thrive in this dynamic cosmic environment. The journey of understanding space weather is ongoing, and it's a journey we're all taking together. Keep looking up, keep exploring, and keep wondering, because the universe is full of mysteries waiting to be unveiled. And who knows what incredible discoveries await us as we continue to unravel the science of space weather.